Okay, so today what we're going over are triangle congruence theorems. Okay, yesterday you guys, or the other day you guys learned that in order for two triangles to be congruent, all of their corresponding parts had to be congruent, right? So all three corresponding angles had to be congruent, and then all three corresponding sides, right? And so that's how we could tell that the triangles were congruent. Okay, was that every part matched up and it was the same size. Okay. Now, today we have some triangle congruence theorems we're going to talk about, and these are kind of like the shortcuts of how to tell if two triangles are congruent, okay? So let's say maybe they don't give you all the information about the triangle, like you don't know all, like every single angle and every single side, okay? We can do some shortcuts to prove that two triangles are congruent, okay? So these shortcuts are the theorems we're going to be learning about today, all right? Okay, so let's take a look at the first definition that I want to go over today, which is the definition for included side, okay? So an included side in a triangle is the side which is shared by two angles. Okay, so on the front side of your paper, this should be the first box that you're filling in your note sheet for included side. Now, your note sheet kind of has where you're just like filling in the blanks for this definition, right? Okay, and then there's a picture on your note sheet. And on that picture, I want you to label the triangle XYZ. Okay, and label two of the angles. So we're going to be talking about the included side for angle X and angle Z. Okay, now if you think about the word included, like if you're included in something, you're like part of the group, right? So when we're talking about the included side, we're talking about the side that's in the group with angle X and angle Z here, okay? So the included side is going to be side XZ, okay? So can you guys highlight or like darken that side or draw an arrow to it and write down that that is the included side? Okay, and the reason why it's that one is considered the included side is it's because it's between those two angles that I had labeled there. Okay, so the non-included sides are the other two. See how XY, is XY going between the two marked angles? No, so that's not an included side. The other side that you have there is ZY. ZY going between the two marked angles? No. So that one's not considered an included side. Okay? So an included side is the one between the two angles that we're referencing. Okay? Now, the included side can change depending on which angles I'm using as my reference angles. Does that make sense? So let's say, for example, I were to change the angles to X and Y. Then the included side would be which side? Well, which side is between angle X and angle Y? XY, right? So the side that you consider to be included is dependent on the angles that are being referenced. Okay? All right, are there any questions on that one? Okay, all right, so let's then talk about our first triangle congruence theorem, okay? So our first triangle congruence theorem is the angle side angle postulate, okay? Now, here's what the angle side angle postulate says. It says that if we have two angles and the included side of one triangle And all that stuff is going to be congruent to two angles and the included side of another triangle. Then that means that the entire triangle, all the parts of each one are going to be congruent to each other, that the two triangles are congruent. Okay, so fill in the missing words in the definition and fill in the markings on your pictures and label your triangles like A, B, C, and D, E, F. Okay, do all the labeling for your pictures. Okay, so does anyone need more time right there, filling in just those two boxes? Okay, so in the notes box, you guys are going to write down that if you have all of these parts congruent, angle A is congruent to angle D, segment AC is congruent to segment DF, and angle C is congruent to angle F, then by the angle side angle postulate, the entire triangles are congruent. Okay, so triangle ABC is congruent to triangle DEF. Okay, so this is known as, for short, we can abbreviate it, saying angle, side angle. Instead of writing that out every time, we can just write ASA, just the acronym to abbreviate it. Okay. Okay, so when we're looking at a picture of two triangles, okay, like for example in this picture, here's what you have, right? You have an angle, a side that's in between that angle and the other angle, right? So you basically have here angle, side, and then another angle, right? And you have that same type of congruence in the other triangle. You have an angle, the included side, or the side in between, right? And then another angle, right? So if you have angle, side, angle in both of the triangles congruent, that means the entire triangles, like each of the entire triangles, are congruent to each other. Okay, it's a shortcut. So even though we don't see up there that all 6 things are marked congruent, if we have those 3 things in that order, okay, the angle, the side in between, and then the other angle in each triangle, we can say that yes, then the triangles are congruent to each other. Okay, so it's a shortcut. All right, are there questions on that? Any questions? Okay. All right, so let's take a look at some examples. Okay, so you have these 2 examples on your note-taking sheet. And on your note-taking sheet, the directions say, are the 2 triangles congruent? If yes, write the congruent statement. State the theorem or postulate that proves the triangles are congruent, and list the required 3 pairs of evidence. If no, briefly explain why not. Okay? All right, so let's look at example 1. Okay. In these 2 triangles, do they have an angle congruent to each other? Well, can you guys actually see the 2 different triangles in example 1? Can you see there's one over here? Do you guys see this triangle? And then there's another triangle over here. Can you guys see that? Can you see how it's separated into 2 triangles? Okay. What do you have marked in each triangle? Congruent angles, right? This angle here, it's showing you, is congruent to that angle right there, right? Okay, what other angles are marked congruent? Do they both have a right angle? Yeah, there was one marked here, and then there was another one marked over here, right? Okay, now, I know it's kind of hard to tell from this because it's not actually marked, but one thing you want to look for is, do the triangles share a common side? I want you guys to write this down. Okay, that we always want to check for a common side. Okay, because if the triangles share a side in common, then by default, that side has to be the same length, right? For example, this wall back here, this one with all like the stained glass pictures and the faces on it, I share that wall with Mrs. Tsai in the next room, right? If I measure the wall in my room, because it was shared, and then I just go to the other side of the wall and I measure it again, isn't it going to be the same size? Like, it's the same wall, right? It's not like my wall in here is a different wall than her wall over there in the other room, right? So whether I measure it in here or whether I measure it in the room next door, it's still the same size, okay? So, do these two triangles share a common side? Yes. Okay, look at where the common side is. It's this one, AP, right here, okay? So, if they do share a common side, you can say that that common side is, by default, congruent to itself, right? It's the same size in each triangle, right? So, here's what you end up having. In the blue triangle, you have an angle, a side, and an angle. In the other triangle, you have an angle, a side, and an angle. And these two angles are congruent, right? These two sides are congruent, and then these two angles are congruent, right? So does that follow the angle, side, angle postulate? Yeah. So we can say that, yes, these triangles are congruent. Okay, now, what am I going to call these two triangles? Well, let's call the first triangle, triangle A, what? What order do you guys want to go in? AGP, okay, is congruent to, now if I went in the order AGP, what order do I have to go in for the second triangle? ASP, very good, okay, is congruent to triangle ASP, all right? And we could say this is by the angle, side, angle postulate. Okay, now, the directions told me that I had to, if they were congruent, I had to list the 3 required pairs of evidence. So that means stating which angles are congruent to each other, which sides are congruent to each other, and all of that. So really quickly, I'm going to erase some stuff because this is like a lot of stuff going on here. And let's just really quickly write down which angles are congruent to each other. Okay, so what am I going to call this angle right here? I can't just call it angle A because then I don't know which angle A I'm talking about because there's 2 angle A's. So what do I have to call that angle? Angle GA what? P is congruent to, now what am I going to call the angle in the other triangle? Angle what? SAP, right? Okay, so angle GAP is congruent to angle SAP. Okay, so that's my first piece of evidence, right? Okay, now, what was the common side that I said was congruent? AP. Now, no matter which triangle I'm in, it's in the same order, right? So, segment AP in the triangle on the left is congruent to segment AP in the triangle on the right. Does that make sense there? Okay, and then the last piece of evidence was the right angle, right? So what am I going to call the right angle in the blue triangle? What do you guys want to call it? You can't just call it angle P because there's 2 angle P's. So what are you going to call it? GP what? GPA is congruent to, now what do you have to call the one in the other one? SP what? A. You have to go in the same order, right? So these are your 3 pieces of evidence that are required, okay, to prove that you can use angle, side, angle postulate, all right? Okay, does that make sense what we did there? Okay. All right, let's take a look at the second picture, okay? In the second picture, I see that I have two triangles. I see that some things are already marked congruent, right? Okay, so in this second picture, what do I already have that's marked congruent? Can you guys see the two different triangles, first of all? Can you guys see the one on the left, and then can you also see the one on the right? Okay, so in those two triangles, okay, I see that I have an angle here and an angle here marked, right? I have angle A marked congruent to angle C, okay? I also have a side marked here and here. Are they sharing a common side? Yeah, what's their common side they're sharing? BD. So this can be marked congruent to itself, right? Now, let me ask you guys, what do I have here? I have an angle, a side, and a what? Okay, over here I have an angle, a side, and a what? Okay, is that the same as angle, side, angle? No, okay, it's not the same as angle, side, angle. This order, okay, is saying angle, side, side. Now, does that prove congruence? No. Okay. ASS does not prove congruence. Okay? All right? Are there questions on that one? Okay. So we're going to say no on the second one. The two triangles are not cannot be proven congruent. Okay? Now, it doesn't mean that these triangles necessarily are not congruent. It just means that right now we can't prove them congruent, okay, based on angle, side, side. Okay? Now, one of the things that we neglected to think about was some of the directions with the problem. So it says segment BD bisects angle ABC. So let me go back here and relook at the triangle after seeing those instructions. Okay? So if I wasn't given these instructions, all I had was angle, side, side, which doesn't prove congruence, right? Okay, but now I'm looking at these instructions. It says that this segment BD, you guys see it, is bisecting this angle, ABC. What does it mean if it's bisecting the angle? It's cutting the angle in half. So if it's cutting the angle in half, what am I allowed to do? I'm allowed to say that this part of the angle is congruent to that part of the angle. Okay? So now, look at what I have marked now. Now do I have angle, side, angle? And then in the other triangle, do I also have angle, side, angle? Yes. Okay? So, reading those directions, okay, I have a different setup. I don't have ASS anymore. Okay? Now I actually have something that can prove congruence, right? So now I can actually say yes that the two triangles are congruent, okay, because of angle, side, angle. So we're going to say yes, and we're going to write the triangle congruence statement. Okay, so our triangle congruence statement here is triangle ABD is congruent to triangle CBD. Okay, by the angle, side, angle postulate. I'm going to just abbreviate that. Okay, now it wanted me to list my 3 pairs of evidence, right? So what are my 3 pairs of evidence that I have? Well, what's the first angle? What is this angle and this angle over here? What are those 2 angles going to be called? Angle A is congruent to angle what? Angle C. Okay? All right, now, list their side that they have congruence. So what is the included side over here called? Side what? AB. And then on the other triangle, what is the side called? CB. And then the last pair of evidence is that last angle that I labeled. Okay? So, in the first triangle, it's called angle ABD. And it's congruent to, in the second triangle, it's called angle CBD. Okay? All right. Are there questions on that one? Okay. So in that one, at first, it didn't look like it was going to be congruent because all we had was ASS. Okay, but then after that, if I go back and read the instructions and mark some things based on the instructions, I found that I do actually have angle side angle there. Okay? All right. Any questions on that stuff so far? Okay. All right. Let's go ahead and turn your note sheet over to the other side. Okay. Okay. Your next definition we're going to talk about is called the non-included side. Okay, so everyone go ahead and fill this into your boxes and label your picture, please. Okay. All right, so the non-included side. What is a non-included side? A non-included side is a side not shared by two angles. Okay? So it is not being shared by two angles. All right, in your diagram, label, we're talking about angle Z and angle X again in this diagram. So the non-included side for angle X and angle Z is going to be not the one in between. The one in between them was this one, right? That's the in-between side. So we're not talking about that side because it's not in between. It's the other sides, okay? So the other sides that are not in between can be XY, or it could be talking about YZ. Okay? So it's talking about either one of those sides. XY or YZ are considered non-included. Bless you. Okay? All right. It cannot be side XZ. That is the included side. Okay, do you guys need more time writing things down or labeling the diagram? Yeah? Okay. All right, you guys still need more time? We're good? Okay. All right, so let's look at the next triangle congruence theorem. It is the angle-side theorem. Okay? So, here's what the angle-side theorem says. It says if you have two angles and the non-included side of one triangle. So let's label that triangle up there and say this is what you have. We have two angles and the non-included side are marked. And those are marked congruent to two angles and the non-included side of another triangle. So you have the same markings like that in another triangle. Then that proves that the two triangles are congruent. All of their parts are congruent if we have this. Okay, so if we have all these parts congruent, then that means that those two triangles are congruent, okay? And so for short, we just shorten this as AAS. So angle side theorem. Okay, so do you guys see how in this one, the side that's marked it's not in between the two angles, like in the last one? Okay, so when I'm looking at these two, I have an angle, right? I'm going this direction, and then I'm going around, and then I have a side. Does that make sense? And that's the same way it is in the other triangle, right? Okay. So that's why this is called angle side as opposed to angle side angle. Okay. All right, are there questions on this one so far? Okay, so let's take a look at some examples. Okay, so on your paper, it says, wants to know, are the two triangles congruent? If yes, write the congruent statement, state the theorem or postulate that proves it, and then list the required 3 pairs of evidence. Okay, so let's look at example number 3. Okay, we're going to still look for a common side. Okay, so let's look for a common side. Do we have a common side? Yeah. Which side is it? WY. So this side is congruent to itself, right? Now, they both had an angle here, right? One in this triangle, one in that triangle. Okay, is there any other information we know about these two triangles? So in the top triangle, I have an angle and a side, and in the bottom triangle, I have an angle and a side. Is there a third piece of information, like another angle or another side marked congruent? Anything? No. So can I say that these two triangles are congruent based off of that? No. Okay. I don't know that they are congruent. Okay. So I can say that in this one we cannot prove the two triangles congruent. Okay, and my reason here can be that I don't have enough information. Because there were no other instructions or anything there that gave me any indicator of anything else. Okay. All right. So let's take a look at example 4, okay? On example 4, do you have a side congruent? Do they have a common side? Yeah, that can get marked congruent to itself, right? Now, I see that this one has an angle here, this one has an angle here, so I have an angle and a side so far in the two triangles. Now, one thing that I want you guys to notice in this set of triangles, what do these markings right here mean? It means I have what kind of lines? Parallel lines, okay? So I'm going to like redraw something here off to the side for you guys, but I want you to think about this. When you have parallel lines cut by a transversal, do you get some congruent angles? Do you actually get quite a lot of congruent angles? Okay, one of the angle types that is congruent, remember, is alternate interior. Do you guys remember the positioning of alternate interior angles? Okay, so do I have alternate interior angles between parallel lines in this diagram? Look at this angle here is alternate interior with which one? That one right there. I want you to mark those congruent on your paper, please. Okay, they are congruent because they are alternate interior angles between parallel lines. Okay, so now that you have those marked congruent, let's look at what we have. In the bottom triangle, we have an angle going around this way, right? Then we have another angle, and then we have a side. Okay? Now, let's look up here. We have an angle, so I'm going around this way, and then a side. So do they both have the same pattern? Yes, okay? So, can we say that these are congruent? Yes, okay? So, let's identify the two congruent triangles. So we're going to say here, yes, the triangles are congruent, right? What are the congruent triangles? Sorry, I know I have a lot going on, so I'll erase and just mark some of the important stuff. Oops. Okay, so what are we going to call the top triangle, the blue triangle? What do you guys want to call it? DEF, okay? So triangle DEF is congruent to, now what do you guys want to call the bottom triangle? If you called the top one DEF, what letter do you have to start with on the bottom one? Okay, D has 2 marks. Which one in the bottom has 2 marks? F, okay. And then now, if you went to E next, E had 1 mark. Which one in the pink triangle has 1 mark? G. And then last would be what? D. Is everyone understanding how we got those ordered? Yes or no? Yeah? Okay, so yes, those are the 2 congruent triangles. Now, we also need to take a look at what are the 3 pieces of evidence, okay? So one of the pieces of evidence, okay, remember, we had an angle, and a side, right? So what is this first angle over here called? Angle what? Angle E is congruent to, what angle is it congruent to in the other triangle? Angle G. Okay. All right, now, what's the next angle we have? Start with the blue triangle again. What is the next angle? Well, it's angle D, but can I just call it angle D? I can? No. There's 2 angle Ds, right? How do I know if I'm talking about this one or this one here? I don't know, right? So I'm going to call it, D has to be the middle letter, E, D, what? F. Okay, now, in the other triangle, that's angle F, but I can't just call it angle F. So what am I going to call it? Okay. Well, if I started with E in the blue one, which angle do I have to start with in the pink one? Which angle goes with E? G. Then I can go to F and then D. Okay. All right, okay, last, the congruent side. In the blue triangle, if I call this side DE, and I know this is going to be like super confusing for you guys, I can't call it DE in the other triangle. Because look at this angle D. How many marks does it have? 2. Which letter has 2 marks in the pink triangle? Yeah. Hold on. Yes, I'm going to call this side DF is congruent to side FG. Okay?